Imagine standing on a street corner, blinking your eyes. And when you open them, the skyline has physically changed. This is not a magic trick. It is not a computer-generated simulation. It is a weapon in an industrial war that the Western world did not even know was being fought. While we spend years arguing over permits and pouring concrete, Chinese engineers have cracked a code that defies physics. How do you build a 50-story skyscraper in a single day? The answer is not just speed. It is a terrifyingly brilliant reinvention of how human beings live. For the last 100 years, the way we build skyscrapers has barely changed. We dig a hole, pour wet concrete. We wait for it to dry. It is a slow, dirty, dangerous, and incredibly wasteful process. In New York or London, a skyscraper takes 5 years to complete. In that time, budgets balloon, interest rates rise, and the technology designed for the building becomes obsolete before the doors even open. But what if the building itself was a problem? If construction fails to evolve, we face a global crisis. We need to build the equivalent of a new New York City every single month for the next 40 years, just to house everyone. The traditional methods are simply too slow, keep civilization from collapsing under the weight of its own housing crisis. The engineering paradox is massive. To build fast, you usually sacrifice stability. To build light, you sacrifice strength. They had to invent a new material, one that is 10 times lighter than concrete, but strong enough to withstand a magnitude 9 earthquake. But the real secret? The secret that allows them to defy time itself lies in a single, microscopic component hidden inside the walls. A detail so small, you would miss it if you were holding it in your hand. To understand the genius of this new method, we must first understand the enemy: concrete. In the construction industry, we call traditional building the wet trade. It is the bottleneck of every major project on Earth. Concrete is heavy. It is messy. But most importantly, it is chemically demanding. When you pour a concrete floor, you have to wait for the chemical reaction of hydration to occur. This takes days, sometimes weeks, to reach structural integrity. This waiting game is why Western construction sites look like ghost towns half the time. You are literally watching paint dry, but on an industrial scale. Furthermore, concrete requires formwork, temporary wooden or metal molds. Building these molds takes time. Stripping them takes time. It is a logistical nightmare that burns money and hours. Chinese engineers looked at this process and realized that the only way to achieve record-breaking speed was to eliminate the wet trade entirely. They needed to banish concrete from the superstructure.
Look at the revisions here.
This decision was the first step in a revolution
by tomorrow.
that would turn the construction site into an assembly line. The solution they developed is known as the B-core slab. If you cut open the floor of a traditional skyscraper, you find solid concrete reinforced with steel bars. But if you were to slice open the floor of this rapid build tower, you would see something that looks more like the wing of a fighter jet. The B-core slab consists of 2 thin plates of stainless steel. Sandwiched between them is a forest of millions of tiny, thin-walled steel tubes. These tubes are arranged vertically, acting like a honeycomb. This exponentially increases the stiffness of the panel without adding significant weight. But here is where the science gets incredible. You cannot just weld these millions of tubes to the plates. Instead, they use a process called copper brazing. The entire sandwich, plates, tubes, thin sheets of copper foil, is placed into a massive furnace. At 1,100 degrees Celsius, the copper melts, but the steel does not. The liquid copper flows into the joints, fusing them together with an atomic bond that is incredibly strong.
I know it's crossed out, but the original premise was
This
sound.
results in
We
a
just need to
slab
factor
that
in
is
heat radiation.
90% air, yet holds massive loads. And most importantly for our 24-hour deadline, it is finished the moment it leaves the oven. There is no drying time. It is a finished structural component ready for war. This material innovation is the foundation upon which the entire speed record rests. Now that the material exists, the battle moves to the factory floor. In this new model, 90% of the work is moved indoors. This is the concept of modular construction taken to its absolute limit. The engineers applied car factory logic to a skyscraper. They do not build a building, they build modules. A module is a massive, three-dimensional box containing the floor, the ceiling, and the structural columns all in one unit. Inside the factory, workers are installing the walls, the windows, the flooring, and even the toilets and the kitchen sinks. When a module rolls off the assembly line, it is a finished room. You could literally walk inside and turn on the lights. Lasers measure the dimensions of every steel beam. If a beam is off by even 2 millimeters, it is rejected. This precision is critical. If the bottom module is misaligned by a fraction of an inch, the building will be leaning over by several feet once you reach the 50th floor.
Get everyone out of there!
Once the modules are built, a new challenge emerges. Logistics. You need to get them to the center of a crowded city, and you need to do it fast. The planning required for the transport phase is mind-bending. The 24-hour deadline is lost if the crane sits idle. It requires a just-in-time delivery system that rivals the best supply chains in the world. The project managers know exactly where every single room of the skyscraper is at any given second. The route through the city is pre-planned to avoid low bridges and tight turns. Police escorts clear the way. It is a continuous conveyor belt of steel moving from the factory to the site. While the modules are flying down the highway, something crucial is happening at the site itself. Normally, digging a foundation and pouring the basement is the longest part of skyscraper construction, taking months. To bypass this, the team utilizes preformed foundation anchors. They drive massive piles deep into the bedrock. On top of these piles, they place a massive, prefabricated steel adapter plate. They use laser leveling tools to ensure it is perfectly flat relative to the gravity of the Earth. This preparation is the unsung hero of the process.
Keep coming back, steady now. All right, hold it right there.
The stage is set.
Pay
The actors are
attention
ready.
to this specific area.
The curtain is about to
The
rise.
foundation must be set by
Clock starts.
1600 hours.
The first module is lifted into the air.
Right into place. Looks
This
good
is the
from here.
moment of truth. The crew
Make sure
is
the seal is
surprisingly
tight.
small. You only need a crane operator and a handful of specialized technicians. As the crane lowers the module, giant guide pins help align it with the one below. It is a male-to-female connection system. Gravity does most of the work. As soon as the module touches down, workers move in with power tools. They do not weld the connections. Instead, they use high-strength bolts. These are tension-control bolts that are tightened until the head literally snaps off. This ensures that every single bolt is torqued to the exact mathematical specification required. The speed is blistering. One floor creates the platform for the next. There is no scaffolding wrapping the building because the walls are already finished. 3 modules make a floor. Bolt, click, tighten. Next. The building rises visibly, floor by floor, almost like a time-lapse video playing in real life. Passers-by stop and stare, unable to comprehend the rate of ascent. It creates a psychological disconnect. Our brains are trained to think large things move slowly. Seeing a skyline change in real time is jarring. A building is more than just steel and glass. It is a living machine. It has veins and arteries, the water pipes. It has a nervous system, the electrical wiring. The engineers developed a proprietary plug-and-play coupling system. When the modules are bolted together, the pipes are automatically aligned.
Negative, switch to channel 3. I repeat, switch to channel 3. We have a critical situation at sector 4. Move it.
As the final floor is bolted into place, a terrifying question remains. Is it safe? They built a full-scale replica and placed it on a massive shake table. They dialed the machine up to magnitude 9. When the machine turned on, the building shook violently, but it did not crack. The millions of tiny tubes in the B-core slabs acted like shock absorbers. Physics, it turns out, is on the side of speed. So, how do you build a 50-story skyscraper in 24 hours? You do not.
Shut it down.
You
shut
build it
down
over
now.
months in a factory, perfecting every millimeter, and then you assemble it in 24 hours. The spectacle of the one-day build is just the tip of the iceberg. The real revolution is the invisible supply chain, the brave materials science, and the complete reimagining of what a building is. And now, the payoff. Remember the microscopic secret I mentioned at the start? It is the copper brazing foil. That paper-thin sheet of copper, melted between the steel tubes, creates a bond that is actually stronger than the steel itself. But as we look at these gleaming steel towers, a new question arises. What happens when we need to build where there are no factories? The next frontier of construction is not steel modules. It is autonomous swarms of 3D printing robots using Martian soil. And believe it or not, that technology is already being tested in the deserts of Earth right now.
I can't believe it. Are you getting this? It's beautiful.
Orbital stability is nominal, but the dust here is remarkable. We need to analyze the atmospheric density before descent.